Hi guys, I want to share with you a pretty interesting circuit. The interesting part about this is the use of the built-in Zener diode for protection purpose as a conducting diode, allowing two back-to-back MOSFETs to be used to control an AC load. Let me go and explain that. So this part here is the control, which is isolated from the AC circuit side via an optocoupler. That's U1. Depends on the current that flows through this circuit here, how much this transistor will conduct, and how much voltage will show here. In turn, this voltage here will be used to control either Q3 or Q4, depending on which half of the AC cycle that we talk about. The power supply to the U1 is derived from a circuit which basically reduced substantially the AC voltage, which is 220 volts, to some manageable level, rectify them through this diode, do filtering, again do more filtering, and then do a Zener to get it to 12 volts, and then some more filtering. So that's just pretty much standard stuff. Now the interesting part about this is on a one cycle, this built-in diode here is actually meant to be helping protecting the MOSFET in the case where the drain voltage is negative with respect to the source. But in this particular case, it's used as a forward conducting diode in one half of a cycle. The red line here shows the current that flows in one direction, in which Q4 acts as a diode, and the blue line here shows the other cycle in which Q3 acts as a diode. So let me elaborate on that a little bit further with the diagrams here. Basically, I redraw these from the circuit, noting that on one half of the cycle, Q4 acts as a conducting diode, and likewise on the other half of the cycle, Q3 acting like a diode. In both halves, the voltage across resistor R4 is used to control the turn on of either the Q3 or the Q4, whichever that is not acting like a conducting diode. So as you see, this circuit is a pretty clever use of two MOSFETs to control an AC load. Thanks for watching.